So, Peter, I mean, we know you from Mars most recently, but you're kind of a solar system tourist because over the length of your career, you've Venus, outer solar system. I mean, talk about some of the missions you've been involved in over the years.
Well, you're right. I actually have started studying the sun was my first
Oh,
job.
wow. Okay. So you've been working your way in
Been
and out
working
of.
my way from the sun all the way outward towards Saturn and
Okay.
actually its biggest moon, Titan,
Right.
and covered most of the planets and objects in between. So the question when we started was, what are these things? I remember going to college at Berkeley in the late 60s, and I took a course in astronomy,
Hmm.
and we spent a week on the planets. And I checked the book out of the library that was the book on planets, and it was one volume that had a chapter on each planet, and that was essentially everything that was known about those planets.
Even at the research level, we didn't know much more than that.
Did not
Because
know
this
much.
is pre-Voyager, I guess, and pre-Viking. So
Pre everything,
right.
well, it's pre Mariner 9,
Wow.
which is the
Okay.
first mapping of the surface.
Hmm.
All we had before this was flybys, where we had a little strip of images, and it looked a lot like the moon.
So this piqued your interest that we knew so little about our
We knew
closest
so
neighbors.
little.
Yeah.
I mean, the ignorance was palpable.
Uh-huh.
So we start from our position of ignorance, and certainly I did.
Hmm.
And my knowledge of the planets all came from science fiction.
Yeah.
I love science fiction. I love the idea of going to planets and interacting with the creatures that might live there and how fun it might be.
Right.
So I'd grown up with that.
And now, since you brought that up, I have to ask you favorites. Who were your?
I liked Edgar Rice Burroughs and
Okay.
his series on John Carter going to Mars.
Right. And some pretty lurid science fiction there from Edgar Rice Burroughs.
It was
Amazonian women on Venus.
and it was beautifully illustrated by what was his name, Freschetti, I think.
Yes. Yes.
His pictures just brought it alive for you. So
Hmm.
it was the kind of thing as a teenager I was totally enraptured with.
Right.
Finding out what the truth of these worlds might be, because we knew nothing.
Hmm.
Nothing.
And was it just personally? Was it even a little disappointing, like when the first images from Mars came back? And it was, it was pretty desert-like and maybe
Well, as a
barren.
scientist, we can't be disappointed in learning truth.
That's true. Yes.
But as a human being wanting adventure and the thrills of exploring alien worlds, yeah, it's been a complete bust.
Right. Although, we can probably leave the door open a crack on weird life on Titan, right? Maybe.
Well, that is
Microbial.
weird life. It's
Yeah.
pretty hard to get excited moving around at 90 degrees Kelvin.
Right. That's true.
You need some pretty heavy insulation.
So continue with how you got into space missions and
Well, my field was optics.
okay.
And so I was building spectrometers to look at the sun. And when I came back to school at the Optical Science Center here at the university, I really sucked up all the optical knowledge I could in 2 years, got a master's, and then went to work with Marty Tomasco, who was building an instrument
Hmm.
that within 6 months of having started in his calibration phase was landing on Venus.
Boy, that was a false sense of instant gratification.
Instant gratification. So my career ideas of being a gemologist went out the window.
Yeah. Right.
And I was totally hooked on exploring space and
Hmm.
seeing it up close for the first time. I mean, this is one of the first American landers to the surface of Venus. The Russians had done it,
Right.
and they had actually taken a picture of the surface, which was rather poor quality, but it showed a pile of flat rocks. And so you knew there was a solid surface down there, even though the atmosphere is incredibly thick and hot and, it's definitely uninhabitable, very little water.
Right.
So that's how I started. And then the next thing,
And just as an aside on that, I mean, Venus is kind of still the ugly stepchild in the solar system. Right? Is there?
well, we
any
don't know
interest?
what to do with it.
Should
I
we
mean,
go back?
you can see it from orbit,
Right.
and all you see is the tops of the clouds. And we had the Magellan mission that had a radar, and you could map the surface. But it
Right.
wasn't images. It was radar bouncing off the surface. So it was a little bit
Yeah.
hard to interpret. And what we saw was a very volcanic surface, and we didn't see hardly any craters. And we use craters to date surfaces. So the shock was, where are the craters?
Hmm.
The surface has to be new. within a few 100 million years at the most. And so what happened to the old surface?
So,
Apparently the whole thing, turned over.
wow.
And the surface was completely reshaped.
And that's at a level we don't have on the Earth, that level of volcanism.
We do not. No,
Okay.
we see craters on the Earth.
Mm-hmm.
We see quite a few of them, actually. But most of them have eroded away, so you see the remnants.
And it is our sister planet, so presumably there are lessons there, geological and other lessons.
Well, the lesson is watch out for pumping too much CO2 into the atmosphere.
Right.
You can have a runaway greenhouse, and then you're in real trouble.
Well, as a camera builder, does that not for some hypothetical mission, does that attract you? A camera that wouldn't melt and could do its job on the surface of Venus?
Well, now this is a challenging problem you bring up. Getting a camera to work at 700 Kelvin is not so easy. And yes, it does attract me, but you would have to have a cooling system that would allow you to only survive maybe 20 minutes on the surface. That would be about the best you could hope for.
Right. Which
So,
is not much for whatever fraction of $1
no,
billion.
it's not just
it
the
would
camera.
cost.
I mean, you have to get power from the spacecraft, and you have to be able to transmit signals back. So
Right.
the whole system has to work.
Right.
And
So you got into the space game, and you're the camera dude. Everyone comes to you for a camera, right? And there's a lot.
Yeah.
I don't know. Do you keep count? How many cameras has it been launched from Earth?
I don't keep count. We started with the camera that landed on Titan. It's called DISR, Descent Imager Spectral Radiometer.
Mm-hmm.
And I was a project manager for that and helped with the design. And then using the lessons we'd learned from building that camera system, we proposed to put a camera on Pathfinder.
Mm-hmm.
And we won the competition. This is how it works in space. You have to write a proposal and compete against all the other clever people in the country.
Right.
And I was sort of a dark horse. I'd never even written a scientific paper about Mars.
Right.
And so to choose my camera based on my understanding of optics and projects was a bit of a challenge, I think, for the people at NASA.
And these are brutal competitions. I mean,
Brutal
dozens of proposals and
yes.
down select sequentially, so you don't know for a couple of years, right? You've put in all this work.
This was a fast-paced thing. This was a discovery mission.
Okay.
We got the announcement of opportunity in December, right before Christmas. We started working on it in January. We submitted it in February. And by May, we had the go-ahead to do the project. Of course, the go-ahead started with, but we don't have any money for you this year.
Right.
If you'll just patiently wait till next year and rewrite your schedule to show that, then off you go.
Mm-hmm.
So we built a really nice camera. We called it Impey, Imager for Mars Pathfinder.
Right. And that was your first stepchild leaving
Yes, that's right.
Earth's
That's
gravity?
right. It's still on the surface of Mars. I hope someday it's the center of a children's park or something.
Uh-huh.
It'll be there forever.
So even with some of these fast-track proposals, the whole arc of a mission, this is decade-long commitment, right? I mean, it's a big chunk of your life.
It's the Mars missions are typically 6 or 7 years, assuming you don't have a rover that lasts for 9 years like MER. And the missions to the outer solar system can be 15 or 20 years.
Wow.
The Cassini mission, the mission, the New Horizons going to Pluto.
Right.
These are your entire career is developed around these missions.
Right.
So you want to make sure it's going to be working when it gets there. Otherwise, it's too sad to think about.
Yeah. Sort of like raising a child, you don't know excitement, disappointment, you don't know what's going to happen in the end. Maybe that's not a good analogy.
Don't bring no subjects to mind.
Okay, we'll stick to just hardware here.
Yeah, hardware.
So, and you're remembered, of course, for these great cameras and for Phoenix in particular locally, but it's not all roses, right? There's highs and lows in this game. Not everything succeeds.
Well, you think you have it worked out when you write the proposal and when you do the first phase of the mission. Everything is something you can visualize. You can see how it will all work, and you have it all planned out. And then, of course, something happens. And this is true of every single development. Something happens that is totally unexpected, and you go into crisis mode. Mm-hmm. So for us, it was the motors that are going to allow the camera head to point. Mm-hmm. as of 6 months before delivery, the motors we were using turned out to be unacceptable, and we had to go out and try and find new ones.
Wow, you're talking about Phoenix now.
No,
Oh,
this
you're
is Pathfinder.
Oh, back to Pathfinder. Yeah.
I'm
right.
sorry, back to
Okay.
Pathfinder.
Mm-hmm.
And so we had an incredible crunch in the last few months,
Right.
working through Christmas and finally delivering on New Year's Day.
Mm-hmm.
We finally got our camera in 1 day late.
Yeah.
But anyway, that's the challenge with these missions, is that there's always something that you visualized would be fairly easy to do turns out to be nearly impossible.
Right. And sometimes your part of it works just dandy, and there's another problem. So the late 90s, I guess, was not...
Well, you're correct. We had a huge success with Pathfinder, and it was a very popular mission. We landed on July 4th. Turned out to be a slow news day, and people all over the country were watching the first pictures coming back and really just were enamored with the ability, using the new internet, to actually access pictures from Mars on their little computers. It was tremendously exciting. So after the big success of Pathfinder and driving a little rover and doing all the things we did,
the first rover.
The first rover on Mars. And after,
and remind us how tiny that was compared to Curiosity.
It was described as the size of a bread box or a small microwave.
Okay.
About 2 feet long. And after that huge success, we started the next mission to land in a polar region on Mars, the South Pole. Mm-hmm. And everything was going great until we hit the upper atmosphere and the spacecraft disappeared and was never heard from again. So we still to this day don't know precisely what happened.
Wow.
So
that's hard when you don't know what happened. How do you learn?
The worst kind of failure. We never got a single picture from our cameras.
Right. And you didn't know what even happened.
Didn't even know what happened.
Right. So of course, Phoenix, the name is.
It's the reflight of that mission that was lost, except not to the South Pole. We went to the North Pole. And not right on the polar ice cap, but nearby in what you'd probably think of as a permafrost region on the Earth, sort of like northern Canada.
Right.
So there was ice near the surface, we were told, and we went to find out about that ice.
And I'm sure many people were asking this, including higher up NASA people, as the mission approached, but you'd resuscitated a mission that had failed, and people must have asked you, well, have you figured out all the things that could go wrong?
Well, that's a very good point. Talk about a challenge. The spacecraft had already been built, but it was the sister spacecraft to the one that crashed, and we didn't have a good resolution on just what the errors were. So we had to find problems inside of the sister spacecraft, which meant lots of testing.
Right.
And through our tests, we found one after another of things that could go wrong on a regular basis throughout. Every month it seemed like it was something new until we had 25 different failure modes identified and fixed. 25. And so, unfortunately, the last one was found 2 months before launch. And the administrators are going, well, isn't this supposed to flatten out this curve? It's almost a straight line. It keeps going up. What about number 26?
Last couple of months you're supposed to be at the beach because you're so confident.
Supposed to be at the beach. And now we're finding failure modes and fortunately able to correct. But we had to convince our NASA administrators that we'd found all of them, even though the curve we were showing was a straight line rising at the same rate at the end as at the beginning.
Okay. I'm sure you did a great job convincing the NASA administrators, but what about inside? Were you still a little nervous or confident?
Well, this is going to sound strange, but when we finally launched the spacecraft, it was at 5:30 in the morning, and off it went with its 9 solid rockets, dropping 1 minute and then 2 minutes out. They all dropped and tumbled down, but it left this huge contrail in the sky. And the wind in the upper atmosphere blew this contrail around, and then the rising sun lit it up into all kinds of interesting rainbow colors, and it had precisely the shape of a phoenix bird. It looked like It looked like an old Batman cartoon, where they project Batman, the bat, into the sky.
Yeah.
And so that gave me a lot of confidence. I shouldn't believe in omens and signs, but
why not?
But that just made my heart so glad, and I thought, this is going to be a wonderful mission. Look at this sign. Why else would it have been there?
So talk about, people recently saw this with Curiosity, but talk about what it feels like in the control room for the descent. You know, that critical time when bad things can happen. It's all happening really fast, and you don't actually have control of the situation. What is that like?
Well, there was a lot of nervous people in the control room with me, and I was fairly confident, as I said. I'd seen the cloud after takeoff, and
Right.
and just in my heart, I believed this was going to be a mission that was going to be a great success. And I also, not just the cloud, of course, I'd worked with the engineers both at Lockheed Martin and at the Jet Propulsion Lab, and these were really experienced, knowledgeable, talented people that
Yeah.
worked through all the problems to conclusion, and I had tremendous faith in them.
Mm-hmm.
And so when we started counting down, you know, to when we hit the upper atmosphere, and again, there's a 15-minute delay, so whatever has happened has already happened.
Right.
So you're looking at history.
You could be fatalistic at that level.
Yeah. So is it alive on the surface or dead? It's a little like Schrodinger's cat. You know, you have to open the box to find out.
Right.
We had to wait 15 minutes to know whether we're alive or dead on Mars, and some of the administrators were really almost feeling physically sick because they had a mission called Mars Science Lander, now called Curiosity, that was at that time going to launch in 2009, and the entire reputation of the Jet Propulsion Lab and of Lockheed Martin was based on the success of Phoenix,
Right.
because it was the same people working the landing on both.
Yeah.
And so they were nervous as heck if this thing crashed, what would be the repercussions, you know, to the Jet Propulsion Lab? Would they have to shut down their new missions? And so there was a lot riding on this. And the exciting thing to me was as we were counting down, there was the engineer who was expressing, you know, each waypoint as we came down. You know, the parachute has been extended, the thrusters are on, that sort of thing. And we had to come up with failure modes and write press releases for each one.
Oh my gosh!
So we had a stack
it's like
of press
writing your own
releases.
obituary.
It's
multiple times. Right?
Yeah, and not knowing the cause of death.
Right.
So you've got the obituaries for yourself for every imaginable cause of death. Oh, major heart attack. Poor Smith lies crawling across the floor, can't get up. Whatever, you know. And
we could write some fun ones, like electrocuted while playing in a rock concert at Wembley Stadium or something. We could have fun with it.
That's true. That's true.
So
Some are not very plausible, though.
So you wrote all these. Wow.
So I didn't write it, but the press agent was standing across the room, out of sight of the cameras. And as we went through each critical point in the landing, he was tearing up these press releases and throwing them up in the air, so they were falling like confetti.
Nice.
And one after another, the confetti was going up until the floor was covered in white, like it snowed over there. And it was kind of the thrilling thing, you know, to see each possible point where you could have failed the entire mission has been passed by and never to come again.
Yeah.
So until finally we landed safely and everybody was thrilled. And then we had to wait for the orbiters to come around because they were our communication link to actually get the first picture down, and it was a beauty. I mean, we were just thrilled.
I remember your excitement. I remember an event, it was a media event here, maybe here, and you were playing air guitar. You were definitely feeling it.
Yeah, well, all my friends and family and colleagues were here in Tucson celebrating the landing, and they could see it all on the big screen.
Right.
But I had to be in the control room at the Jet Propulsion Lab, so I was, you know...
Yeah.
I mean, I didn't want to hug and kiss Charles Alachi. I wanted to be with my wife.
Right.
So when I finally came back, they had the press here and everybody standing out congratulating us on our wonderful safe landing. And somebody called me a rock star of science, so I was pretending to play an air guitar, and somebody photographed it and put it on the front page of our newspaper. So
that's great. Let's talk a little bit about Phoenix, because there were some remarkable results. I mean, the business of seeing a hydrological cycle, and there's an incredible concept of, you know, a liquid, you know, because people just don't think of liquid on Mars, and you had this briny liquid. So
that's right.
Talk a little about what excited you about what the mission did.
Well, I'll talk about our number one what has turned out to be our number one most important result, and that was the discovery of a salt called perchlorate.
Okay.
We think it's calcium perchlorate. Now, perchlorate means that there's a chlorine atom, and it's surrounded by 4 oxygens.
Mm-hmm.
It has, I think, a couple of negative charges, and it can combine with calcium.
It's like a cleaning fluid type
It's not.
ingredient? No?
That's chlorate,
Okay.
or hypochlorite,
Okay.
and those are bleach.
Shows my chemistry is pretty
Yeah,
shabby.
well, mine was shabby too. We all thought, well, that's the end of organics on Mars.
Uh-huh.
But perchlorate, because of the 4 oxygens, form almost a pyramid around the chlorine. It's a very stable configuration,
Right.
unless you heat it up.
Mm-hmm.
And this is the key thing. If you get it above 200 C, it starts to release the oxygens. And so we had an experiment designed for measuring organics. And as you put perchlorate in with the soil, hopefully with some organics in there, as soon as you get above 200, the oxygen's released, and it combusts all the organics, and all you get is water and CO2 coming out.
Wow.
And we saw water and CO2, but we couldn't prove that there was any organics in there.
Mm-hmm.
So it's very frustrating. And now we see Curiosity has found exactly the same thing. They found perchlorate, and they see CO2 in water, and there's a couple of chlorohydrocarbons, but they're not sure what that means yet.
Because in this chemistry landscape, the availability of organics is key. I mean, for people talking about habitability and so on. And I guess that's been controversial since Viking.
Well, Viking kind of, how would you say, it kind of took all the enthusiasm out of us that were looking for life.
Right.
Because they said there are no organic materials on the surface at a part per billion.
Wow. And the ambiguity of the wolf trap experiment, that didn't really...
There was other experiments that indicated that there was something going on that could have been life, or could have been some very active chemicals.
Mm-hmm.
But without organics, it was hard to imagine that there were microbes in the surface. So we really do not believe there's such a thing as silicon-based life, or any other element. Carbon is the one.
The science fiction fan in you might like to think that could possibly happen.
Sure, maybe there's life on the sun. I mean, you can imagine anything you want, but when you get into the real science of it, it's very hard to build the kind of complex chemistry that life requires out of a silicon-based organism.
So bringing into play other Mars information for the last 5 or 10 years, how have we come to this view that Mars was habitable in the past, if not now?
Well, the perchlorate has an interesting implication for the Viking experiment that found no organics, and that is that they had perchlorate in the soil, and instead of seeing organics, they saw CO2 and water, which they had trouble measuring for various reasons of the instrument, because there was lots of it, and it's just more added to what they could see. There's CO2, the atmosphere is CO2 after all. And so we think that the Viking results were incorrect, that there might be as much as several parts per million of organics, enough to...
In the sense that the data was incorrect, or interpretation, or what was...
They did not take into account perchlorate inside of their ovens.
I see. Okay. So when they interpreted...
Because they didn't know. They didn't know there was perchlorate in their ovens.
Right.
And, of course, the people that ran the experiment vehemently deny this and say that, no, that can't be right. But we're seeing the same thing with Curiosity, and it has other capabilities. So I suspect very strongly in the next few months, and this is right on the edge of our research, that they're going to settle this question once and for all, if there are organics on Mars.
Right.
And so if you have organics, and you have all the building blocks of life, which we call schnapps, that's sulfur, carbon, hydrogen, nitrogen, oxygen, and phosphorus.
You're getting me excited because it's only a few hours from cocktail hour here. I thought you were going to bring out a bottle.
It's 5:30 somewhere.
Okay, that's true.
So we see all the elements that you can create life from. And now if you got organic materials and they're stable on the surface, all you need is some liquid water. And what we found at our Phoenix site was that we did see droplets of liquid water, but they were not pure water, they were brines, and they were perchlorate brines. Perchlorate has the property at high concentrations of lowering the freezing point down to minus 70 centigrade, which is below the average temperature of Mars.
It's a huge effect.
And Alfred McEwen, with his HiRISE telescope, has seen flow patterns that only occur in the summer and seem to be temperature-driven, and look for all the world like liquid water. But again, liquid water is not stable because it's too cold and the pressure's too low. So he's thinking brines also.
So we're talking now about eruption of brine, episodic eruption of briny liquids.
Yes.
Wow.
And the other thing about perchlorate is on the Earth it is a energy source for microbes.
Okay.
So microbes not only don't mind perchlorate,
microbes?
They live on it.
What kind of weird microbes, sort of extremophile type things?
Yeah, they're extremophiles. That's right. There's a fellow at Berkeley, Professor Coates, and he's been studying these perchlorate-eating organisms for the last 15 years.
Okay.
And has found a really incredible world of perchlorate-eating microbes.
So it's not just food, you're talking ecosystem based
An
on
ecosystem,
chlorate.
exactly.
Wow. So the excitement, had seemed to be tantalizingly far below the surface, subsurface aquifers that are beyond the reach of the rovers and scratching around on the top.
Yeah, well, it doesn't mean it's easy to find life. I mean, it certainly would be trouble right on the surface. Because the UV radiation from the sun is not blocked by an ozone layer as it is on the Earth, and it's very cold there, and they have higher radiation from cosmic rays, and there's just a lot of things that are not ideal on the surface. So, but it doesn't have to be, hundreds of meters deep.
Right.
It could be near the surface.
So now, having just been to a Curiosity conference, that's the hot mission now, and what's bubbling around in that?
Well, they have landed in an ideal location. It's the Gale Crater. And Gale Crater...
Which was another huge decision that I saw got pushed way back.
Yes.
How to down select from 100 sites to 64 or
Well,
whatever.
they wanted the scientists to make the call, but what happened is the science community broke up into 4 equal teams, and each promoted their own favorite site, and so the scientists weren't ever going to decide. So it had to come down to safety and, engineering decisions.
Right.
Although scientists, I think, are all happy with this site. And what we found is that Curiosity landed right at the base of a flow that came off of the crest of the crater. And what I was learning just 2 weeks ago is
a liquid flow or a lava flow?
A liquid flow.
Wow.
But this may have been a long time ago.
Yeah.
It's hard to put a date on it, but apparently there was an ice sheet up on the edge of the crater, and it was melting at its base, and the water could flow out underneath. So the ice sheet, under its high pressure, because it's thick, could allow water to be stable and flow down. And they think this was not perchlorate brines, but very fresh water.
Wow.
And there may have been an ice-covered lake at the bottom of this, and that they're seeing the bottom of a lake bed. And so they are really excited, finding all kinds of things that you could find easily on the Earth, with cracks and gypsum coming up through the cracks and all kinds of interesting things.
Wow. So it built with the last set of rovers, and your mission, but the geochemical evidence for standing water on Mars in the past is incredibly strong now.
It's very strong. I don't think anybody doubts it.
Right.
Well, maybe a few people, but the majority don't doubt it. And we're finding evidence for large pockets of ice still existing today on the surface, even in equatorial regions, but buried under a few meters of soil. And the reason we know that is we actually have a radar orbiting Mars that can penetrate the surface and reflect off of an ice-soil boundary, which would be the bottom of the ice flow.
Oh, wow. So to the orbital cameras, doesn't look that exciting, a few meters of rock, but just under...
Just under the rock, which has flow patterns in it, and something's going on, but under the rock you see that there's an ice layer.
And I've read that the total inventory of water on Mars, if you melted it all, is not trivial. I mean, it's a few centimeters or something around, over the whole planet if you could melt
centimeters? No, 500 meters.
Oh, wow. Okay, so it's actually...
There's a lot of water.
Yeah.
There's a lot of ice to melt, it's... Because all the flow features we see catastrophic flood features that when they were flowing, which probably wasn't for very long, would have carried a higher flow rate than the Amazon River by a factor of 1,000.
Wow.
These are huge, huge floods that we see. So there was a lot of water, and now we don't see any water on the surface, maybe a few tiny little brine features, but that's about it. Everything has gone to ice.
Mm-hmm.
And of course, some of the water is left through the top of the atmosphere. It's either gone up or down. It's not on the surface. And we see the polar caps, and now we know there's a lot of buried ice on Mars.
So if you were a betting man, extant life on Mars, you think? Whether or not we can find it or detect it.
Well, this is pure speculation.
Sure.
I suspect there are places where the brines have concentrated, and you really do have pockets of liquid water, which may not be right on the surface, but may be, under a protective layer, kind of wet soil, so to speak.
Right.
And that would be the place I would suspect there's a possibility of microbes, because if in the earlier climate on Mars, when water was common, if you could have started life, life is so able to evolve into all the little, ecological niches that I suspect it's found a place to survive.
Right.
Now, I don't know for sure that it ever started. If it didn't start, then the game's over. But if it started back when Mars was really habitable, it's probably found a place to survive.
And as far as the future goes, sample return, people get excited about that. It's very expensive. Do you think, is it necessary? Is it worth the cost to have something you can scrutinize atom and molecule by molecule in the lab?
Well, my feeling about this, I know a majority of Mars scientists would really love a sample because there's so many instruments that can analyze these samples and tell you the real truth of what these things are, the age, the concentration of minerals, and so on. But to me, before we spend the billions of dollars that are required, and let's not underestimate the cost, it's very expensive. I think we need to find the place where we want that sample from. Okay. And once we find that place that is so exciting that sample is going to tell us the most we can learn about Mars, particularly about life, then I think it's time to go.
Right. Have you ever wanted to go? I mean, you do a lot of...
Well, I did as a teenager, but now that I'm 65...
Well, they're talking about, one-way missions now. They're dusting off all these... It's a hell of a way to go.
They don't have any good restaurants on Mars, and I guess I'm a little spoiled.
Yeah, it's probably
and, a smelly little spaceship with 6 other people in it doesn't really attract me too much.
For quite a while as well.
Yeah, for many months. So I'd say no, but I'd hope somebody else goes.
I think someone will want to go. But what's next for you?
I think some of your students should go.
Absolutely. What about you? What's bubbling for you?
Well, I'm currently building cameras for the OSIRIS-REx mission.
Right.
That'll go to a nearby Earth-crossing orbit asteroid, and we will be taking pictures with our camera set and finding the best place to take a sample, and we'll grab a sample and bring it back to Earth. So we are doing sample return from an asteroid.
Yeah.
This is already funded and underway. We'll launch in 2016. We'll be taking our first pictures in 2018. So this is a really thrilling mission, and I hope opens the door to understanding the origin of our solar system and the origin of life on Earth, because this is a carbonaceous asteroid that is known to have organic material. So what is it, and does it contain the seeds that could, in the right environment, produce life?
Now, I don't know that you have such a website, but I just imagined you should have the most killer What I Did for My Holidays website, because you've got holiday photos from places nobody has ever been. Have you ever made a website that's just like that? Like my vacation snapshots from...
I'm a very shy man, I don't broadcast the things I've done.
Okay, but I think...
Unless you put a microphone in front of me.
I think a lot of people would go to that website. That would be cool. Well, thanks for talking to me, Peter.
You're very welcome, Chris. Good luck with your course.